Hi everyone, this is Algebra 2, Chapter 4.4, and let's get right into our lesson here. Evaluating functions, linear and quadratic or cubic. When we're graphing a cubic function, we see it in the form of y equals x to the third power. There could be a fraction or a number in front of the variable, but what we're going to do and kind of make the connection here is we're going to have numbers that we're going to utilize for our variable x. We're going to plug that in for x and solve for y. And we're going to use that method that we used before when graphing parabolas. We're going to do -2, -1, 0, 1, 2. I'm going to kind of put the arrangement in a different order, but you could still do, again, -2, -1, 0, 1, 2. I'm just going to put it in a different order. Don't be confused by what I'm doing. And then all we're going to do, now that we have our -2, -1, 0, 1, 2, we're just going to plug it into our x value there on the left-hand side. So what we would get is 0 to the third power. And 0 to the third power is just 0 times 0 times 0. And so that would just equal 0. So my coordinate point would be 0, 0. And then I would have 1 to the third power. Well, that's just 1 times 1 times 1, which is just 1. And then I'd have -1 to the third power. Well, that's -1 times -1, which is a positive 1, times a -1, which would give me -1. Then I'd have 2 to the third power. That's 2 times 2 times 2. Well, 2 times 2 is 4. Times 2 again is going to give me 8. And then I have -2 to the third power. Well, -2 times -2 is a positive 4, times -2 is -8. And just to kind of see an example of what this would look like when you have something to the third power, well, I have 0, 0 as a point. And then I have 1, 1. We'll say that's right here. And then I have -1, 1. We'll say that's right here. And then I have 2, 8. Let's just say that's way up here. And then I have the reversal of -2, -8. We'll say that's right here. And so you kind of get this interesting shape like this. And so that's what a cubic function would look like. And again, you're just plugging in your x values for x and solving for y and then graphing it. We had done that before with quadratics, so you are very familiar with this, and it should be relatively easy. So I'm going to do 2a together with you, and then you're going to do 2b on your own, and you're going to graph it. So I'm going to draw my table here. And then, again, we're going to have our -2, -1, 0, 1, 2. I'm just going to list it out differently. That's just how my notes are that I have. 1, -1, 2, -2. I am going to plug 0 in for x. So what I would get is 7 over 8 times 0 to the third power. What that gives me is I have to use order of operations here. So I have to deal with the exponent first. 0 to the third power is just 0. So I get 7/8 times 0. Well, that's just 0. For 1, I get 7/8 times 1 to the third power. Well, 1 times 1 times 1 is just 1. So I get 7/8 times 1, and that just gives me 7/8. Then we have -1. Well, your answer, if you plug those in just to make things go faster, is just 7/8. Or sorry, -7/8. And then let's kind of move everything down here so it's not too crazy. There we go. Then we have 7/8 times 2 to the third power. That gives me 7/8 times 8, which is just 8 over 1. and our 8's cross cancel. That just gives me 7. And I know this, since it's a -2, it'd just be the reversal. So it'd be -7. So again, I did this fast because we have so much practice with this using x squared. X to the cube is just another level up. Very easy if you have a calculator. If you don't have a calculator, it can be challenging at times. Let's go ahead and graph this. So I have 0, 0 right there. My next coordinate is 1 and then 7/8, which is almost a 1, comma 1. So that's going to be about right there. And don't worry if it's not perfect. My next coordinate is -1, 7/8. So that's going to be roughly right there. Then I have 2, comma 7. That is going to be right there. And then I have -2, comma -7. And that is right there. And then what you would do, I kind of usually start from the point. It's going to look like that. And then this one is going to go there. Okay? So that's that one. You're going to use the same coordinate plane to do 2b on your own, and then we'll cover it in class if there's any misconceptions or misunderstandings. All right, moving on here, we have a polynomial in standard form is of the form a sub n x to the nth power plus a sub n minus 1 x minus 1 up there as the exponent, and then so on and so forth. That seems crazy, it seems confusing, so let's break it down very simply. We have two vocabulary terms. We have degree of the polynomial. Degree of the polynomial is the degree of the leading term, the highest exponent. And again, I'm going to break this down so it's very easy to remember. And then the leading coefficient is the coefficient, number multiplied to the variable of the leading term. So let me give you an example. Here I'm going to have 3x to the 4th, okay? Degree of the polynomial is the degree of the leading term, the highest exponent. Okay, so let's draw an arrow pointing to the exponent for your studying. And then for leading coefficient is the coefficient number multiplied to the variable. That's 3 times x to the 4th of the leading term. So this one down here is going to be our 3. Okay, so that's that. Coefficient is just the number before the variable, and then the degree is basically the highest exponent, or the largest exponent you can think of. And I'll show you what I mean right now. We're looking at degree and leading coefficient of a univariate polynomial. And what it wants us to do is identify the degree of the polynomial and its leading coefficient. Well, that's key words, okay? So let's highlight degree of the polynomial and then leading coefficient, okay? What this is saying, degree of the polynomial, is our largest exponent. And you're going to want to put that in your notes for memory. Sorry, largest exponent, singular. And then when it's dealing with leading coefficient, let's just make a note for ourselves here that this is number in front of the variable number in front of the variable with the largest exponent. Sorry, my pen is not working that great. With the largest exponent. And forgive my penmanship as always. I know I talk about that a lot. Okay, so let's look at 3a, and then you're going to do 3b on your own. I have 18y to the 4th power minus 10y minus 15 minus 9y to the 6th. So what I zoom in on is I want to find, of what's here, I want to find which one has the largest exponent. We'll have the exponent of 4, 1, nothing, and then 6. Well, this one this right here, negative 9y to the 6th power, is my greatest exponent. So what we have here is our leading term. Okay, our leading term is going to be negative 9y to the 6th, meaning if I rearranged this problem, and that's in 3a here, is I would have negative 9y to the 6th plus 18y to the 4th minus 10y minus 15. So that's what we mean by leading term. Now, our answer is we want to be able to identify the degree. So here's where we're going to write our answer in our solution. Our degree is going to equal our exponent. Our exponent is 6, so that's our degree. Our leading coefficient, is going to be the number that's in front of the variable with the largest exponent. And again, that's what we highlighted. They're multiplying together. That's a negative 9 times a y to the 6th power. So we're taking the number or the term in front of that, and that's going to be negative 9. And that's our answer. Okay? So to make this very, very simple, you're just finding the greatest exponent. You want to find the number that's attached to it along with its sign. Here's a negative. And then the degree is just the exponent, and then the leading term is just the number in front of it. So that should be really easy to do 3b on your own. Go ahead and do 3c and 3d on your own as well, utilizing the steps that we did in 3a. What I will say here for 3c that will be beneficial for you, please don't forget that in front of a variable there's technically a 1, and you're going to need to utilize that in your answer. So your leading coefficient for 3c would be 1. Just know that, and I think you're more than capable of doing those 3 on your own. Alrighty, so now we're getting into solving an equation of the form x cubed equals a using integers. And what it says here is solve and simplify. If there's more than one answer, separate with commas. If there's no solution, write answer as no solution. And it says no, Alex does not give you a calculator. So I'm sure all of you are aware of that. Let's go through these. And I want to go through these because, as it's said here, it is useful to recognize the first 10 cubes. And hopefully you all have seen this. But let's do 1 to the 3rd power. Well, 1 to the 3rd power is just 1. 2 to the 3rd power is 8. Right, that's 2 times 2 times 2. 3 to the 3rd power is 27. 4 to the 3rd power is 64, right? 4 times 4 times 4. Or if you want to see it, it looks like this. 5 to the 3rd power is 125. 6 to the 3rd power is 216. 7 to the 3rd power is 343. 8 to the 3rd power is 512. 9 to the 3rd power is 729. And then 10 to the 3rd power equals 1,000. So it is really beneficial to be able to recognize, and if you want to memorize those, you can. If you don't have a calculator, you could still do it freehand. It's just going to take a little bit longer. Or again, you could just memorize it and make your life a lot easier on things. So we're going to have to utilize these and kind of almost work backwards. And you'll see what I mean by doing 4a. So here we have u to the 3rd power equals 8. What we want to do right here is we want to figure out what number raised to the 3rd power equals 8. Okay, what number raised to the third power equals 8? Well, I know by looking here it's going to be 2, right? 2 to the third power equals 8. But let's kind of do this long form. So what we want to do is we want to get rid of that exponent of 3. So I'm going to have u to the third power equals 8. Well, what we do to get rid of an exponent is you want to take the square root. And whatever I do to the left-hand side, I have to do to the what? The right-hand side. And this is more of what we would call a cube root. So instead of a square root, we have a cubed root here. So let's add in our 3. What happens here is cube root of a cube is gone. So we're left with u equals the cube root of 8. Okay. Well, what's the cube root of 8? U equals 2. Right? 2 cubed is 8. So you might be very familiar with doing square root, right? Square is 2. Cube root would be 3. So this might be new for some of you, but to recap on this and to assimilate what you would do for if you had u squared, say, equals 16, well, to get rid of that square up there, you have to square root it like this, right? And right here, we don't normally write 2, but it would be the same thing. It'd be like that. And then you would just get u equals 4. Okay, so trying to assimilate what we did a long time ago as well as in Algebra 1. Well, let's do B together, and then you could do 4C and 4A on your own. Or should I say you could do what's highlighted here. This should probably be 4D. Let's do this one together. So I have a negative. What you're going to do is you're going to take the cubed root of u to the third power. I have negative 64 cubed. This is different than saying the square root of negative 64, folks, okay? Square root of a negative is different. We would have to deal with I, our imaginary numbers. Here we're dealing with cube roots, so there is a difference. Well, what's the cubed root of just 64, right? So what's the cubed root of 64? Well, 4 to the third power is 64. So if I know that it's 4 to the third power is 64, well, I know that then negative 4 would give me negative 64. And we'll see that in a second, okay? So our solution is u equals negative 4. Furthermore, I knew that it was 4 because 4 cubed right here, 4 cubed that I'm highlighting right here in green, is 64. So I know my answer has to be 4. Now there's a way to check this if you're still not sure of your answer. There is a way to check this. You can do negative 4 times negative 4 times negative 4. That would be 4 cubed. Well, negative 4 times negative 4 is a positive 16. And then I'd have to bring down my negative 4. And if I did 16 times negative 4, well, that does give me negative 64. Thus, you know that you are correct. So I might be going a little too far in detail on here. I hope I'm not. But if you do need it, then I am glad that I did. And of course, we'll cover this again in class. Go ahead and do 4C and 4D on your own, the ones that are highlighted in green. I can see here that there is a little bit of an error. This should be 4, then the letter D here, 4D. All right, moving on. Finding the x and y intercepts given a polynomial function. We want to find all the x-intercepts and y-intercepts of a graph of a function. So this is very similar to what we did with the quadratic functions and setting it equal to 0 and solving. And you'll see what I mean by that in a second here. So we're going to do 5a together, and you're going to do 5b on your own. So what we have here is what we first want to do is to find the y-intercept by setting x equal to 0 and solving for y. So let's go ahead and do that. So to find, and I think it'll be helpful to write this out, to find our y-intercept, what we're going to do is set our x's equal to 0, and then we'll solve for y. And this should look really familiar to you from our prior chapters, and that's why I'm going to kind of do this relatively quickly. So here, again, we're going to find our y-intercept. If you were confused of what that is, our y-intercept is right here. Okay, that's our y. In other words, our output, right? So our y is 2. And then for x, we're just going to plug in our zeros, okay, plus 12 times 0 squared plus 16 times 0. Well, if you notice something here, 0 to the third power is 0. 2 times 0 is just 0. Plus, and I'm going to do this long form for those that want to see it visually. I need to deal with exponents first. So 2, 0 to the third power is just 0, plus 12, 0 to the second power is just 0, and then I have still 16 times 0. We'll just solve that in the next line here. 2 times 0, 0, 12 times 0, 0, 16 times 0, 0. Thus, my y-intercept is going to equal 0. Okay? That's one part of the question. Now, let's see if we can, I'm going to collapse this one on the left-hand side just so I have some room. And I'm going to collapse that. All right. Now, we're going to do our next part, and what our next part is, let me collapse this too. Okay. Why don't I do my next part, the second step in blue here? So to find our x-intercepts now, we're going to set our y equal to 0 now and solve. And solve. And I'll collapse this to make this just a little bit smaller. Alrighty, so let's set our y equal to 0. So now we have 0 equals 2x cubed plus 12x squared plus 16x. Well, this is where we need to recall from a prior unit, but what we need to do is factor out our greatest common factor of what we have here. 0 equals 2x cubed plus 12x squared plus 16x. Well, our greatest common factor, and let me write this out in words here, factor out our greatest common factor. Well, what goes into 2x cubed but also goes into 12x squared, but also goes into 16x? That is going to be, our greatest common factor is going to be 2x. I can pull out a 2x out of that entire polynomial. So what we have here is 0 equals my greatest common factor, and when I take that out, what I'm left with is x squared plus 6x plus 8. Now this should look, at least what I have here underlined in purple, this should look relatively familiar on something that you can factor again. And if it doesn't, hopefully in this next step it will. So now that I have that, what I can do is factor what's in parentheses there, my quadratic. Well, I want to find I want to find, let's see if I can get a straighter line. I want to find a number that multiplies to give me 8, but adds together to give me 6. Well, I know 4 times 2 multiplies to give me 8. 4 plus 2 adds together to give me 6. So what I have is 0 equals, I have what I factored out, 2x. I have x plus 4. That's what we just found when we factored out our x squared plus 6x plus x. And I have x plus 2. So that just came from right here and right here. From there, what we need to do is set all parts with an x equal to 0 and solve. So let's make a note here. Set all parts with an x equal to 0 and solve. So hopefully you can make that a little bit cleaner. So all parts with an x equal to 0. Well, I have a 2x there, so I'm going to have 2x equals 0. I have an x plus 4 in parentheses, so I'm going to have an x plus 4 here equals 0. And then I'm going to have my x plus 2 equals 0. And from there, you're just going to solve for each equation. So I need to divide by 2, x equals, 0 divided by 2 is just 0. I need a minus 4 to both sides. That gives me x equals negative 4. Minus 2 to both sides, and x equals negative 2. So my x-intercepts equal 0, negative 4, and 2. And that's what it's asking us for. So usually our y-intercept might have been 0, or it would depend on the quadratic. And usually for x-intercept, we just had 2 answers, right? That's where it would cross prior, just to make the connection to last semester. It crossed at one point there on the y-intercept, right? We always usually had one answer. And then it crossed here on the x-axis. So our x-intercepts would have had 2 answers. It is possible to have had 3. But what we're looking at here is possibly something going like that maybe. So it's 1, 2, 3 x-intercepts, if that makes sense. And then it'd be crossing at the y-intercept at one point, and it just erased. But that's what's basically happening here. I'm going to guess you probably want me to do the next one and help you out with that, and then you could do 5C and 5D on your own. So originally I had you doing all 3 on your own, but let's do this next one together as well. So first step here is I want to find my y-intercept. Okay, and to do that, you need to set your x's equal to 0, right? So I have y equals x to the, or should I say 0 to the 3rd power, minus 4 times 0 squared minus 4 times 0 plus 16. Let's go ahead and simplify that. 0 to the 3rd power is just 0 minus 4 times 0 to the 2nd power is 0. I'll put that in parentheses. Minus 4 times 0 plus 16. Well, what we get is 0 minus 4 times 0 is 0, minus 4 times 0 is 0, and then plus 16. So that's going to equal 16. Thus, my y-intercept is 16. So that's the first part. That's probably the easiest part. Everybody should be able to do that one. Now, I'm going to shrink this just so I have room. Alrighty. Then for my x-intercept, what I want to do is set my y equal to 0. Okay, so I have 0 equals x to the third power minus 4x squared minus 4x plus 16. If you remember, there is the greatest common factor, but on this one, and I'm hopefully pulling from your long-term memory now, is we want to what's called factor by grouping. Okay, factor by grouping. We'll put underline and make it fancy. What factor by grouping is, just to kind of review it or to help you recall it, 0 equals x to the third power minus 4x squared. And what we're going to do is group these. We're going to put parentheses around them. And then what we have is minus 4x plus 16. And then we're going to group those together. Okay? And what this is going to allow us to do, it's going to allow us to pull out a greatest common factor. And it's going to allow us to pull a greatest common factor from each grouping. And you'll see what I mean by that right now. So the greatest common factor here for this first group is going to equal, well, I need to figure out something that goes into x cubed minus 4x squared. Well, what goes into both of those is an x squared. And then my greatest common factor here, well, I need to figure out something that goes into negative 4x and a positive 16. Well, negative 4 goes into both of those. So now that I know my greatest common factors, I can write it out. So I have 0 equals, I have my x squared, that was my greatest common factor, x minus 4, right? I pulled that out. So if you redistributed the x squared, you would have gotten what you have when you factored it, or before you factored it. Minus 4, and then you have x minus 4 again. So we've had practice on this. You guys have seen this. This is nothing new. From there, what you want to do is set it equal to, or should I say, let's group these together again in a way, just to make things easier visually. I'll have x squared minus 4. Okay, if you're confused where I got that from, I combined our greatest common factors there. And then what I have here is, that's x squared minus 4, so I have x minus 4 right here. All right, so just to kind of recap a little bit, it might seem like a lot. For our x-intercepts, what I needed to do was set everything equal to 0, or my y equal to 0. From there, we needed to factor by grouping. To factor by grouping, I grouped out my x cubed minus my 4x squared, and then my negative 4x plus 16. And then I found the greatest common factor of both. From there, I rewrote it, and then what I did was I grouped them together again. From there, what we can do, now we can actually solve. So you want to set each one equal to 0, right? So I would have x squared minus 4 equals 0, and then add x minus 4 equals 0. Let's solve each one. You have to add 4 to both sides, and what you're left with is x squared equals 4. Well, how do I get rid of that exponent? Well, we learned that you then take the square root, and that will get rid of the 2. And whatever I do to the left-hand side, I have to do to the right. So what you're left with is x equals 2. And then the right one-hand side is super easy, right? Add 4 to both sides, you get x equals 4. And I should actually make a correction, and forgive me for this. When you take the square root, this is not just x equals 2, and I'm glad I caught this before. When we take the square root, it's x plus or minus 2. Plus or minus. The reason why, if you're curious why it's plus or minus, negative 2 times negative 2 gives me what? Gives me 4. 2 times 2 gives me what? 4. So that's why that's the case there. Meaning, and what this means is for our solution, and let me shrink this down as well. Let's see if it will let me. There we go. What this means here is my x-intercept, or intercepts, are 4, 2, negative 2. And that's my solution. So our y-intercept is 16, our x-intercept is 4, 2, and negative 2. So I'm glad that I ended up doing 5b because it is factored by grouping, and I think it was really helpful to show you that and be able to make that connection to your prior learning and prior understanding to solve that one. So what will help here is basically 5a, and I'll highlight these for you. 5a and 5c are very similar in steps, where you're just going to factor out a greatest common factor, whereas your 5b and 5d, you're going to have to factor by grouping. And I think that will be really helpful stepwise if you guys utilize your notes to solve those on your own. All right, moving on here is we have determined the end behavior of the graph of a polynomial function. So you're going to have seen this before, but we're going to kind of add in some new stuff. So it says the simplest example of a polynomial with an odd degree. Remember, degree is talking about an exponent, right? With an odd exponent. So like odd numbers would be 1, 3, 5, 7, etc. Okay? So what happens here with an odd degree? Let's do green. An odd degree is our linear function. And if you remember what a linear function is, and I hope you do, linear function is y equals x. And when you have that, your line goes right through the origin. And what we have is a line that looks like this. Okay? For an odd degree, that's what your linear line is going to be. Now, it says sketch a line with a positive slope. If you remember, a positive slope is like this, and a negative slope looks like that. And that's coming from Algebra 1, and we spent an entire semester on lines as well. Well, here's something interesting. The simplest example of a polynomial with an even degree, so something a little bit different. Last one was odd, this one's even. You're going to get a quadratic. A quadratic function. As an example, y equals x squared. And what that would look like is you would get a parabola, right? So sketch a parabola with a positive value. Well, you were able to identify that previously in other chapters. That's like that. And then a negative parabola is our face down. That is all review. You have all seen that before. We're just trying to make the connection here to when talking about our exponents. And that's what these examples are down here. It says, describe the end behavior of the graph of each polynomial function. Write your answer in the form rises/falls to the left/right and rises/falls to the left/right. Well, let's look at 6a here. 6a says f of x equals negative 3x to the 5th power minus 3x squared plus 7x squared minus 9x. So I want to look at my leading coefficient here. My leading coefficient would be right here. Okay? That's what I'm zooming in on when I'm doing these problems. What I notice is there's a negative coefficient with an odd exponent. What that tells me is that this is going to rise to the left, comma, falls to the right. And some of you might be like, that doesn't make any sense to me. Right? Let's see it visually, and let's make the connection to what we did up at the top here. So when there's an odd degree, so we have a 5, we're going to have a line, right? Okay. Well, right now, my degree down there in 6a is 5. That's an odd number, right? Odd degree. So I know that I'm going to have a line. Well, what I need to dictate is if that line is a positive slope or a negative slope. Well, I have a negative number there. So my slope, or my line, will look like this. If you notice, just for help to make the connection here, it is rising up to the left, right? I'm just showing you it's going up and then left. And then it's falling down to the right, okay? So that's where I'm getting that from, and to help you just make that connection there. So I'm going to do, I'll do, which ones do I want to do? I'll do 6b. How about I do 6b? And then you should be able to do 6c and then 6d on your own, and we'll cover them in class. So here I have x squared and then 3x minus 5 squared. Let's do that let's break that out in long form. So let's just rewrite our problem. That's going to be helpful visual-wise. And then remember, it's 3x minus 5 squared, so that's just saying it's written twice. Well, let's kind of break that out even more by foiling that whole thing. 3x times 3x is 9x squared. 3x minus 5x is negative 15x. Negative 5 times 3x is negative 15x. And then negative 5 times negative 5 is a plus 25. We need to then combine like terms. X squared. I have 9x squared minus 30x plus 25. And then what I'm going to do is I'm going to distribute that x squared. I'm going to distribute my x squared now. This is where you have to remember the properties of exponents lesson that we utilized. When the bases are the same and we're multiplying, you add the exponents. Bases are the same. I get 9x to the 4th power. I have to add the exponents. Minus 30x cubed. There's a 1 as an exponent above that x, right? And then plus 25x squared. Now that I did that, what I need to do is I need to focus on my leading coefficient, or we'll just leave it as that. My leading coefficient here, my leading terms, or term, 9x to the 4th, right? I'm focusing on the one that has the greatest exponent. Well, I notice that this is a positive. Okay, that's going to help me. Positive, and this number, my exponent, is even. So I need to look at this up here. It says the simplest example of a polynomial with an even degree, that's what I have, is 4. So I know it's going to be a parabola. Well, my coefficient is positive, so I'm going to have a positive parabola. Okay, let's just draw it first this time, and now we'll have our answer. Well, what this is, it's rises to the left, comma, rises to the right. Right, it's right. I mean, you can see it, right? This portion here is rising to the left, and this portion here is rising to the right. I know I drew them kind of going straight up, but you can maybe help you redraw it a little bit. We'll just make it a little bit more dramatic then. We'll make it like that. That way you can visually see even better that it's rising to the left and rising to the right. that's going to be our answer, and that's what they're looking for. You're going to want to do 6C on your own and then 6D on your own. And we're almost done. We're almost done. Hang in there. So I'm going to do one of these on my own, and then you're going to do the other one on your own. So it says choose the graph of each function from the choices below, properties to look for x-intercepts and or end behavior. Well, what I'm looking for here is I'm looking at my leading coefficient, the one with the greatest exponent here, negative 4x squared. All right, well, this is a negative number, or should I say best way to use our terminology effectively is negative coefficient. Okay, and then it's an even degree. And I'll put that up here, even degree. Well, what that shows us, right, is when I have an even degree, I'm dealing with a parabola. I need to decide, is this parabola facing up or is it facing down? Well, it's a negative coefficient, so I know that I'm going to have it facing down. Okay, well, let's kind of look at our options down here a little bit. Okay, I have a bunch of different graphs here, and I want to see the ones that kind of look like a parabola and are facing down. Well, of my options, the ones that are facing down and kind of look like a parabola are graph D and graph E. So I'm going to be looking at kind of those two options. None of the other graphs kind of fit this one. So since that is the case, it could be graph D or graph E. Well, let's kind of find out here. Let's find out by utilizing where it crosses the x-intercept or the x-axis. And to do that, I need to set y equal to 0. I have negative 4x to the fourth plus 8x to the third power. Well, let me pull out my GCF, my greatest common factor. My greatest common factor is negative 4x to the third power. And what I would be left with after I take out a negative 4x to the fourth power, I'm just left with x. And once I take out negative 4x to the third power out of that 8x cubed, I'm just left with a negative 2. Well, from there, if I set both equal to 0, so I have negative 4x cubed equals 0, and I have x minus 2 equals 0, well, this would just lead me to be x equals 0 and x equals 2. So I can find out where it crosses the x-axis on this one. So let's see. So it's going to be at x equals 0. Well, they both equal 0. And I need to zoom in here. What I'm looking at here is I am looking at graph D specifically because it's crossing at exactly 0, 0. Whereas this one, it sounds weird, but it doesn't look like it's exactly right there, and it's not crossing the x-intercept. It looks like it's intercepting right here at, what is that, maybe 0.5. So I have here and here. So this one's actually kind of tricky, but it would be graph, it would be, oh, I might have said graph E, I'm sorry, graph D, I thought this said D. So graph D right here. So we would have graph D. Forgive me. That does cross right there. And there. And if you were even more confused by that, what you could do even further, which isn't really going to work out here, but see where it crosses the y-intercept. And then you would even get even more of an accurate answer. So go ahead and try 7D on your own. What we're going to do in class is we're going to cover this again, the matching graphs of polynomial functions, we'll go a little bit more in depth on it with practice in class. So if you're not fully understanding it and you're fully still confused why it's graph D and not graph E, I will cover that again in more detail in class. So don't worry. For a 5B, try that on your own. And then what you will do is utilize the graph options down here at the bottom, and you should come out to help you a little bit, is you should come out to graph A. So I'm giving you the answer, but I want you to do the work and see if that's what you get as well. And hopefully I didn't make a mistake. With that, that is the conclusion of chapter 4.4. Thank you, everyone, and take care.